Okay, at number 50, we're given an equation. Well, maybe we're not given an equation. We're given a general form for the, anyway, for something. So we have feet, height is in feet, and t is in seconds. So initial height of 100, that's your h sub 0. Your initial height is 100. And its initial velocity, which is v sub 0, is 512 feet per second. So our equation should look like this, plus 512 t's plus 100. Okay, that will be the equation that will model the height of this rocket for any given time t. So hopefully we understand what this will look like. It starts at 100 and it goes up into the air. Eventually it turns around and comes back down. Okay, to the ground. Where this is, of course, the vertex, which is negative b over 2a, comma f of negative b over 2a. This is how we find the vertex, by taking the negative of this and dividing it by that. So when does it reach its maximum height? That is the x value right here. So it reaches its maximum height at negative 512 divided by 2 times negative 16. So 512 divided by 32 after 16 seconds. That is the x value for your vertex. So after 16 seconds, the rocket reaches its maximum height. Ooh, what is the maximum height? So we simply need to plug 16 into each of these t values and see what the answer is. So negative 16 times 16 squared plus 512 times 16 plus 100 is 4,196 feet. So that's the y value here, 4,196. That's the y value for this 16. When does it hit the ground? So that's going to come down here, and you want to find the x value when t is 0, or when h is 0. Negative 16 t squared plus 512 t plus 100. Okay, the quickest way is probably going to be the quadratic formula. Negative b plus and minus the square root of 512 squared minus 4 times a times c all over 2a's. Okay, so I'm going to pause the video and put this into my calculator and see what we get. Okay, I get a t value of 32.2 seconds. Okay, which makes sense because here at 32 it would have been once again at 100 feet, and then a little bit past that is when it's going to hit the ground. So next question, at what 2 times is it 200 feet above the ground? So here's our 200. So now we want this to be 200 equals negative 16t squared plus 512t plus 100. So if I just solve this for 0, or rather solve this for, well, move the 200 over, that's my equation, and I'm going to see when this one equals 0. So let me pause it for a second. So those two times are 0.19 seconds and 32 seconds, approximately, are the 2 times when this thing will be 200 feet above the ground. Okay, so I used my calculator and I saw when this equation right here was 0, and it happened to be here and there. How fun.